Number 4, we're supposed to graph the function, so we'll begin by making a table of values. I've got my x, which are my inputs, and my y values, which are my outputs, and they're very specific. They say domain, so the set of my inputs is going to be 0, 1, 2, 3, 4, and 5. If we plug those in to this equation, for example, if I plug in 0 for x, half of 0 is 0, plus 1 will be 1. Half of 1 is a half, plus 1 will be 1.5. Let me sneak it in there. Half of 2, half times 2 is 1, plus this additional 1 makes 2. Half of 3 is 1.5, plus 1 makes 2.5. You can kind of see our pattern. It's going up by a half each time. This is going to be 3, and this is going to be 3.5. When we plot our points, every point we have an x, y coordinate. And example, we've got when x is 0, y is 1. When x is 1, y is 1.5. We're going to plot those points. We always plug the x coordinate first and the y coordinate. So we move left or right, and then we can move up or down. You have to move into the elevator before you can move up and down it. So we've got the point 0, 1. We'll go left or right 0 and up 1. We will have over 1, up 1.5, over 2, up 2, over 3, up 2.5, and each time it's getting bigger by a half. Over 5, up 3.5 would be right there. And kind of our little key that we know we did things right, if all of our dots are in a line, because we're doing linear algebra right now, this checks out. We don't connect the dots with a line because they were very specific about the inputs. They said only use these values. So I don't want to connect the dots, signifying that I could use any values for x. We're only using those 6, so we only have 6 points out.